Okay, so not a ton of examples of each of these because, again, should look familiar to us. In our long division in your assignment tonight is you are going to see two different types of directions. So let me point out the difference in the directions. The first set of directions is going to ask you to factor completely, and that's actually, I like this section better because it is more of a little bit of a window into what we are going to use division for in this chapter. Is to help us actually factor out a polynomial. When it asks us to do that, I want you to think about, we've talked about over the last couple of days what our different types of answers look like. Our three types of answers are zeros, factors, and polynomials, right? So when they ask me for zeros, it's a list of numbers. When they ask me for factors, it's a bunch of parentheses, right? And when they ask me for a polynomial, it looks something like that. So when we're done with this one, we should have a bunch of parentheses because it asks us for factors or to factor completely. So how do we set up long division? Whatever you are dividing by, you're going to write first outside of your divide symbol. Go back to elementary school and grab that elementary divide symbol. Okay, whatever you are dividing goes inside of that. And what you need to do as we are writing this is make sure that as I start at whatever exponent I start at, which would be an x cubed, that I hit every single then degree on my way down to a constant. So I have an x cubed, x squared, x to the first, and a constant. And if we were ever missing any of those terms, we do need to fill that in with a 0. Otherwise, our terms won't match up as we're doing our long division. Okay? And then as we do this, we are 100% going to focus on the first term in that binomial, which is an x. The plus 6, anything after that first term is just along for the ride. It has no impact on what we do or how we make our decisions. Okay? So I look at that x and I say, okay, it's currently an x. I want to multiply it by something to match this term. Well, look at two things. The coefficient, which is a 1, and I want it to be a 1, so we don't need to change that. Its exponent is an x to the first, and I want it to be an x cubed. What do I multiply by? X squared, right? Now, where I put what I'm multiplying by, don't stress over that. You will notice that I always keep mine oh, that's not why I put it there. I would normally put it here. Okay, let's try that. Does not matter. It doesn't actually impact the answer. I will always keep my stuff organized by terms, like terms, so all my x squareds will be in the same column, etc. Once I have that identified, I'm going to take that and distribute it through that binomial. Okay, so I take the x squared, multiply everything here by x squared. X cubed plus 6x squared. And this next step is the step where people tend to make their mistakes. I now need to go through that and subtract everything, or go through and change the sign, distribute a negative through everything. So it's going to be a subtract, subtract. Okay, all the way through, change the sign on everything. When I do that, I can then just combine like terms as they are sitting there. So x cubed minus x cubed is gone. 7x squared minus 6x squared would be 1x squared, and then we need to bring down our next term. And I repeat the process. I go back to my first term over here, and I say, okay, it's an x. I want it to be an x squared. So we would multiply. The 1's already a 1. I need it to be an x squared. I'd multiply by x. So I take that x, I distribute it all the way through, which would give me x squared plus 6x. Go through, subtract, subtract. Change the sign on everything. Your first term should always eliminate. X squared minus x squared, gone. 4x minus 6x would be negative 2x. Bring down, if we continue to bring down the next term until we run out of next terms. Okay, and then I repeat the process one more time. I have an x to the first, I want a negative 2x. So this is the first time we have to adjust the coefficient. It's by multiplication. I have a 1, I want a negative 2, I multiply by negative 2. I have an x to the first, I want an x to the first, so we wouldn't multiply by any x's, right? We already have the exponent that we want. So I take that negative 2 and I distribute it through, which would give me negative 2x minus 12. Go through, Now this time I have negatives in there, so when I subtract a negative, it looks like a plus, right? I'm just going through and changing the signs on everything. Subtract, subtract. Negative 2 plus 2 is gone, and then this is the first time we're going to see this. Negative 12 plus 12 is gone. In this section, when it says factor completely, you should get a 0 here at the end. It should go into it evenly, and if it doesn't, something went wrong, because they are telling us that this is a factor and it's going to help us factor it completely, okay? So that's a good red flag if something were to be anything other than a 0 at that point. Now, how do I write my answer? Part of your answer is what we divided by, and that's the part that everyone forgets. Don't forget that that is a factor of this polynomial because it goes into it evenly. So x plus 6 is one of the factors that needs to be in my answer. The other part is what we got at the top of our divide bar here. So we'd have an x squared plus x minus 2. Now, the directions do say factor completely, so if I ever have something higher than an x to the first, I would look at it a little closer and say, can that factor further? Are there factors of negative 2 that add up to 1?
Plus 2, negative 1.
Yep, so we would finish out by factoring this. One more step here, positive 2 and negative 1. That would be our final answer completely factored. It doesn't always factor, but we do need to look at it to see if it would. That's how we attack the problem if it says factor completely. Sometimes it's going to ask us just to divide using long division. So let's look at a problem like that. When it says divide using long division, it might end with a remainder of 0, but there's a good chance that we're going to have a remainder other than 0 if it's not asking us to factor. Okay? So let's go ahead and get this one set up. I want you guys to start the divide process, and then we'll talk about how do we deal with the fact that the remainder is not 0. And if you get a 0 remainder, something went wrong, because it's not going to be. Thanks. So remember, as we're doing our divide, the first term, or the first monomial in that polynomial, is what we make our decision based off of. What follows that is just along for the ride. So we will only focus on the x, and the minus 4 just gets multiplied by whatever we make our decision by, the x. So we've got an x to the first. I want it to match 6x squared. So I would have to multiply 1 by 6 to get the 6. I'd have to multiply x to the first by x to the first to give me an x squared. So I'm going to take a 6x and distribute it all the way through that binomial, which would give me 6x squared minus 24x. And then before I combine my terms, I'm going to go through and subtract, change the sign on everything, and then just combine my terms. 6 minus 6 is gone. Negative 26 plus 24 would be a negative 2x. Bring down my next term and start over. I've got an x to the first. I want a negative 2x. So I would have to multiply x by 1 by negative 2. And my x to the first is already there. So take a negative 2 and distribute through. We would have negative 2x plus 8. Go through and subtract. Change the sign on everything. My negative 2 plus 2 is gone, and we are left with 4. Now, how do I know when I'm done? Well, first of all, I have nothing left to bring down. Second, as soon as this term is a degree less than your leading term, like this is an x to the first and this would be an x to the 0, you're done. You can't multiply this by something to get a degree less than what's there, okay? So that's when I would know I was done. And what we are looking at here is a remainder. So how then do I write my answer? My answer comes from, again, what was on top of that divide bar, so 6x minus 2. And then what I want you guys to do to avoid mistakes is always make it a plus and a fraction. Whatever you got as your remainder over what you were dividing by. Okay? Now, I'll show you on the next example why I want you to do this, but always make this a plus. Put your remainder here, and then what you were dividing by here. Even if your remainder were to be a negative number, I would strongly encourage you to keep the negative with the number itself, because when it becomes a binomial with a negative, we make mistakes and it becomes the wrong answer. So I will always make this a plus and keep any negative that ever shows up with the remainder itself up there. Okay? Any questions on that? All right, our last long division example we need to look at is the reason why long division has to exist, and that is when we are dividing by something more than a binomial. Okay. The other thing that I want you to notice on this one is we are missing a term, so kind of a twofold problem on this one. As I look at the number or the polynomial that's getting divided, we start at an x to the fourth, and we are already missing an x cubed. When you are missing a term, technically you can just leave it as a blank space. You will always see me fill it in as a 0 there. I think we make a lot less mistakes if we do that. So I'm going to hold that place with a 0. We have 0 x cubes. But when I write it out, I'll put a 0 in there. All right, so setting this one up, same as we've always done. 2x squared minus x plus 2. And again, we're going to fill in that missing term here. So 8x to the fourth, fill in the 0, x cubed, plus 6x squared minus 3x plus 1. And then we attack like we've been attacking. So I just focus on the 2x squared. Anything that follows is just along for the ride. I've got a 2x squared. I want an 8x to the fourth. So the coefficient 2, I would need to multiply by 4 to give me 8. And an x squared, I'm too short of an x to the fourth, so I'd have to multiply it by another x squared to get an x to the fourth. Take an 4x squared, multiply it all the way through that trinomial. And then go through and carefully subtract, subtract, subtract all the way through there. Okay, so let's see. My 8x is gone. We'd have 4x cubed and negative 2x squared. Bring down my next term. Go back to my first term, 2x squared. I need to multiply 2 by 2 to give me 4. X cubed, I need to multiply x squared by an x to get an x cubed. Take 2x and distribute it all the way through. And then carefully go through, subtract, subtract, subtract. Combine my terms. Now, what's about to happen it doesn't happen very often, but it can, and that is that 2 terms disappear on this one. 4x cubed minus 4x cubed is gone, and then also negative x squared plus negative 2x squared plus 2x squared is gone. And we're left with negative 7x plus 1. Bring down that next term. Now, we are at an x to the first, and our first term over here is an x squared, which means we're done at that point, and anything left over is a remainder. Yes? It's plus 4. Because I need to go through and change the sign on everything. When I multiply by 4 here, I do get a negative 4. But then we're subtracting a negative or changing the sign on everything. So 0 plus 4 would be a positive 4. OK, so this time our remainder looks like a binomial, and that is OK. And again, keep the negative with it. So my answer, what is on top? 4x squared plus 2x plus your remainder. Keep that entire remainder together. Negative 7x plus 1 over what we divided by, 2x squared minus x plus 2. If you were to slide that negative out front, it would be incorrect unless you factored it out. So unless you factor a negative out of that whole thing and change all the signs to 7x minus 1 and move the negative out front, it's incorrect. So don't move the negative out front. Yes?
Factor out 2x because I have a remainder.
Yeah. Because then technically all of our terms don't have that 2x factor. Other questions? All right, that's long division. We're moving on. Any questions about long division? Now, not my favorite. Lots of places for mistakes. You have to slow down. So many silly mistakes will happen on this. Like we'll say that -3 minus 4 is -8 or +1 or something like that. So many places to make silly mistakes in long division. Take your time, double check your work. Which is why I like synthetic division better. It has its limitations. We will use synthetic division a lot in here because most of the time we're going to be able to use it unless it was like the last problem that had a trinomial for what we were dividing by. But any time that we have a binomial that's of this format, x plus or minus a number, we can always use synthetic division. And I would suggest it, okay? Now, in synthetic division, just like long division, if you are missing a term in anything, you have to fill it in with a 0. So on this one, we are missing a plain x. I would fill that in with a 0. The hard part about synthetic division, the x's don't go into our actual problem. You don't notice that it's missing unless you catch it way up there. So make sure you catch it at the beginning. When we set up our synthetic division, the inside of our synthetic division will be filled in with the coefficients of your polynomial. So 2, -7, 0, which is what's going to catch us if we're not careful, and 5. So if you don't remember this, make a note for yourself, coefficients of the polynomial. And then here's the other trick to synthetic division, is that what they have us currently on our marking here is a factor. They are giving us this in the factor form, x minus 3. In your synthetic division, we need to put the 0 outside of it. Well, if our factor is x minus 3, what's the 0? 3, right? Factors and zeros have opposite signs because I set a factor equal to 0 and solve, giving me the opposite sign. So remembering that we have the opposite sign out here because it's the 0 that goes here, even though in the problem they're going to hand us a factor. Okay? All right, and the last part of this is you just have to remember the pattern. To do the pattern for synthetic division, drop down the first number immediately, always. And then your pattern is this. You take the number on the outside and you are going to multiply the number that's on the bottom. The answer to that multiplication, so whatever we get, whatever it equals, goes right here. 3 times 2 is 6. And then we are going to combine those two numbers. So you're going to combine your like terms. -7 plus 6 is -1. Repeat the process. Number outside times that. 3 times -1 is -3. Combine your terms. 0 plus -3 is -3. 3 times -3 is -9. Combine your terms. And I get -4. Now you notice I just sectioned off that last number. I section it off always. It's not required, but I will always section it off to remind you that this is your remainder. Okay? The last trick to synthetic division is you have to remember then how to format your answer. And I'm going to give you 2 methods. You pick the one that's going to make more sense to you. When you write your answer will always be 1 degree less than what the problem started out as. So our problem started out as an x cubed. My answer is going to start out with an x squared. Or you can work your way backwards. This is your remainder, and then we work our way up. Constant, x to the first, x squared. If there was more, it'd go x cubed, x to the fourth, and you can see how far into that polynomial we would get. Okay? So this is the coefficients of our polynomial, 2, and we are starting at an x squared. -1, x, constant is -3, and then just like with our long division, we're going to do plus our remainder over our divisor. -4 over x minus 3.
So all the last number is just always the remainder.
Last number is always the remainder. You got it. Questions? All right, you try one. Look for missing terms. That's my friendly reminder so you don't get too far into this without forgetting that part of it. All right, let's check our setup. Did you remember to put the 0 in there? It should have showed up between the -4 and the 7. You were missing an x squared term. Did you remember to use the opposite sign? Should be a -2 sitting out front. Good so far? Okay, follow our pattern. -2 times 3 is -6, plus 5 is -1. -2 times -1 is 2, plus -4 is -2. -2 times -2 is 4, plus 0 is 4. -2 times 4 is -8, plus 7 is -1. -2 times -1 is 2, plus 3 is 5, which would be our remainder. Putting that into our polynomial, it will start at an x to the 4th, or work your way up from the bottom. So 3x to the 4th minus 1x cubed minus 2x squared plus 4x minus 1 plus our remainder over the factor x plus 2. The one thing I'm going to add to this that is not quite a full problem, but I just want you to be aware of, if we were to get done with our problem, and let's say we have answers that look like this, okay? We did not see an example where a 0 showed up as an answer in your synthetic division. So how do we deal with that in our answer? Well, first of all, do you see that this would start as an x squared, right? That would be our constant, our x to the first, our x squared. So we would have a 3x squared. When it's a 0, it's saying we have 0 of that term. So I don't have any plain x's. I would just move on to the next term, which would be a plus 1. And then plus 4 over whatever we were dividing by. So you just don't include that term when you write out your final answer. Questions? All right. Your assignment tonight is out of the book. I will put that back up there. But you guys